Thanks for coming out. So this is quite exciting for us too, because this is the first time we're allowed to actually speak about our flagship product at a conference. Our marketing guys came up with this title, but essentially we're going to talk about containers, scale, and the DCOS, which is Mesosphere's new product. So as John mentioned, the format of this is sort of a mixture between a presentation and a tutorial/workshop. So we're going to have things which you can follow along with, and at the beginning I gave out 85 USB sticks. There are more than 85 people here, so if you didn't get one, look at a neighbor longingly, or ask someone if you can borrow their memory stick. You just need it to copy the files off, and then you can use it afterwards. We won't get to that for about half an hour, so you have enough time to figure that out. The instructions in these slides, if you type in this URL, this will take you to the presentation. It might be easier to follow along on your laptop than looking at the screen. All right. So what is the container scale problem? I think it's really just like any problem of scale, which is that things fail. And I had a lot of fun last night Googling pictures of container ships failing. But essentially, you have this problem where when you have lots of things, any one of them can fail at any time. The containers can break in real life. In your application, it might just be that one process fails or something like that. And if you're running a lot of these things, you may have applications in different containers, and you want to handle failures gracefully. Another issue we have is basically this idea of orchestration. So how do you stack containers efficiently in real life? And when you're running a big production cluster, how do you pack things efficiently so you're making best use of your resources? So we're going to talk a bit about our answer to these questions, really. So let's talk a bit about the data center as a form factor, and I think this is one of the sort of underlying ideas behind our product. So you have your laptop, your tablet, and your mobile phone, and they're all considered form factors, right? They're discrete sets of devices which you design applications for. So why not consider the data center as just another form factor? It's, when you write a distributed application, you're effectively targeting at this class of appliance, which is a data center. I mean, it doesn't matter that it's 10,000 discrete appliances, it's still one thing, and it's still a form factor. And so we asked, why can't we just run applications on our data center like we run applications on our phones? Wouldn't it be really cool if you had an easy way to switch between applications to see which applications are running, and to write applications for the same set of resources in the same way? Furthermore, applications don't fit on a single machine anymore, and you'll probably know this. We have lots of data, lots of users. Most people have, at least 100 nodes running in their cluster, if not more. Because all of our applications need lots of resources, and resources are things like CPU, memory, and disk. And so really everyone is building distributed systems, but a lot of times people will reinvent the wheel. So we'll go to a lot of effort to re-implement the same primitives every time we want to build a distributed system. And taking this idea of an operating system a bit further, if you look at the Wikipedia definition, an operating system is a collection of software that manages hardware resources and provides common services for computer programs. So it turns out an operating system for the data center is what we really need, because we have all these resources, we have a lot of resources, and everyone keeps trying to reinvent the wheel. So why don't we provide these primitives and common services for these applications so that you don't have to start from scratch every time? And so, as I say, we want an operating system. Just like you have your operating system for your desktop computer or for your server, why can't we have an operating system for your data center that does the same sort of things as you do for your single computer or your phone, but at a much larger scale? So this is what we have. We have the Datacenter Operating System. And this looked better this morning on a bigger screen, but this is what we've been working on at a very high level the last few months, and certainly since Mesosphere began. And so Mesosphere, as a company, we basically provide tools and services around the open source Apache Mesos project. And Mesos is the heart of the DCOS. And I'll explain more about how Mesos works and what it does in the next section. But for now, you can think of it as a kernel of the DCOS. So in a normal operating system, your kernel is responsible for allocating resources to applications. Mesos does the exact same thing, just over thousands of computers. We have some ancillary services we provide. So for instance, Mesos DNS is our service discovery mechanism using DNS, which hooks right very, very natively into Mesos and provides a really easy way to find your running tasks and applications on Mesos. We have a number of frameworks. So Marathon and Kronos are two of our own. We work with a number of partners to provide other frameworks, and we'll demo how easy it is to install those on DCOS later. And then we provide a really nice user interface, because what use is an operating system if it's not easy to use? And we provide a really powerful command line interface for developers like yourselves and ops people, and the repositories. So using the CLI, you can basically package install almost any package you can think of. Right now we have, I think, it's in the double digits, but it's an open specification. Anyone can submit packages to this registry or the repository, and they will immediately become available for anyone with a CLI to install into their data center. And again, we'll show that to you later. So it's really quite exciting. So I talked about the CLI actually. The CLI is what Jose and I work on right now, and it's pretty cool. It's open source, Apache licensed. It's very tightly integrated with our package repository, and we've tried to design it in a way that is congruent with our favorite Unix commands. So if you like Unix, if you like the command line, you'll like the DCOS tool. Note that it also runs on Windows, and if you have a PowerShell console, you can also install it and run it there. Okay, so let's talk a bit about Apache Mesos. So the basic idea of Mesos is to take a collection of machines, so a collection of discrete resources, and model them as one abstract box, which really just represents the amount of CPU, memory, and disk available. So this is really powerful because it means as an application developer, you no longer have to think about hosts. You no longer have to think about my application will run on this host, and this host, consuming this much resource, and this much resource. You just think about a number of resources. So you say my application needs 100 times 3 gig of memory or something like that. And Mesos will figure out where to run it. So this is a sort of fairly common distributed system diagram that you're all familiar with, right? You have a scheduler, so the scheduler is actually new, but you have a master node and you have a number of slave nodes or worker nodes, and essentially the master does the coordination. So it says, I have some work for you, I have some work for you, I have some work for you. Mesos is that level of indirection in this distributed system, and then the scheduler in Mesos terminology, and this is quite important, is the external application. So in our case, a scheduler can be anything from any distributed system to an application, to a sort of platform as a service type application. And we'll show you a few examples of these so they become more concrete. But a very easy example, for instance, is Cassandra. Cassandra can be a scheduler. Mesos basically offers resources to Cassandra. Cassandra accepts some of those, and then Mesos will go and run Cassandra nodes somewhere on your cluster. Where this becomes really powerful is that Mesos supports many schedulers, and it allocates resources fairly amongst the schedulers. I think the policy is called dominant resource fairness, and there's a very readable Mesos paper. This was the sort of inception of Mesos back in 2008, which explains how this algorithm works, and it's still in use today. But essentially, Mesos offers resources to each of the schedulers fairly. This becomes quite powerful because you can basically dynamically allocate how much capacity is given to each of your applications on your cluster over time. And as I'll show you on the next slide, this is great for utilization. So this is a very sort of arbitrary slide because I have no idea where this came from, but who knows? Maybe your application looks like this, maybe it doesn't. But the point is that most usage patterns are different, and often for most big websites, you have sort of anti-correlated usage between your live website, and batch jobs, because typically people are used to writing jobs that run at night because they take up lots of resources. Things like Hadoop jobs. Your website, on the other hand, let's say most of your users are in the US, and most of your developers in the US, they will have a different load at night and different load at day. And so using Mesos, by running all of these tasks on the same set of machines and by setting up your schedulers correctly, you can actually allocate these things dynamically over time, so that during the day your Hadoop cluster maybe takes almost no resources in your cluster, and then at night it ramps up and maybe takes 70%, and your site is still up and running. Mesos takes care of that, but it just doesn't over-allocate it so that you're not wasting capacity. So we actually have a customer who is up to 99% utilization. Admittedly, they do a very special type of they run a very special type of workload, but we typically see that people go from 10 to 20% up to 30% using Mesos, and then you can go even higher if you optimize things correctly. And so just to sort of drill home the picture, really, we have Mesos sitting above all your resources, and then on top of Mesos, you have all your applications. So you have Hadoop, you have Marathon, which is the framework we'll describe shortly. You'll have your own application, you'll have any one of these distributed applications. Twitter recently open sourced a MySQL framework for Mesos, so you can now run MySQL on Mesos. I'd wait a few months before you actually do that, but it's very promising. And so Mesos is in between all of your services in the data center and provides these really useful pieces of functionality. So things like failure detection, package distribution. So you can bundle up artifacts with your application, or you can containerize it and tell Mesos which container you want to run, and Mesos will go and fetch it onto each node and run it. It handles the entire task lifecycle. So this is really interesting, because if you've ever written a distributed system, you'll know that a lot of it is writing networking code. You can implement a framework on top of Mesos' API without writing any networking code. Mesos handles all of that. It provides all the primitives and guarantees various forms of guaranteed delivery, so that you can actually write your application and let Mesos handle all the sort of communication and the usual I forget the word, but yeah. Mesos also provides resource isolation, which is really interesting. So if you're not using containers, it's still containerized. How does this work? So it uses C groups in Linux under the hood, and there are several talks online about how this is implemented in Mesos. C groups, if you're not aware of it, and I'm not hugely familiar with the topic, but it essentially isolates processes from one another, and it places bounds on how many resources they can occupy. So if you have a process and you say, I want this to only use 1 gigahertz of memory, or I think it's, sorry, so you give it a CPU share. So you say there is one core and I want to take that entire core. And if that process starts using more than its fair share, if it starts using more than a core, Linux is responsible for basically killing that process. And Mesos integrates very nicely with this, so that you can very tightly control how your applications run on each host, so that one application that's misbehaving won't take down other applications. This again this helps or provides this multi-tenancy functionality where you can run multiple applications on the same host. Mesos makes sure that these things don't interact with each other, and again that means you can sort of bin pack your applications, so you can run 2 or 3 things on the same host and then drive your utilization up. Part of the C groups thing is resource monitoring, as I mentioned, and Mesos also provides a really nice API to sort of figure out how much resources your applications are using, and we'll show you that with the DCOS cluster later. This is one of the sort of really interesting features we provide, is that we can show you at a glance, assuming everything is running on Mesos, how your resources are being distributed, like which team is using how much CPU, how much disk, how much memory. And we have some really cool features in the pipeline to basically make it easy to segregate clusters. So you could create a custom platform as a service for one of your teams, and you could monitor how many resources they're using and so on. It makes it very easy to share resources in your data center. Mesos also takes care, like I said, of the entire task lifecycle. So things like killing a task if it misbehaves, cleaning up after it if the task finishes or it dies, and so on. So it's all very, very useful. So just just to sort of position Mesos, because you're all probably familiar with things like Heroku, Platform as a Service, and Google App Engine, things like these. And you're also familiar with things like Amazon AWS, Google Compute Engine, or DigitalOcean. You can kind of think of Mesos as somewhere in the middle. So Mesos by itself doesn't provide that functionality to let you run an application. You'll typically have to use something else. We'll talk about Marathon, but there are also many other applications. So Twitter uses a scheduler called Aurora, which does a similar thing to Marathon, which lets you run services. It also lets you run time-scheduled jobs. Netflix has one, I think it's called Singularity. And so people have their own variants of these things, but most of these are open source, and you can kind of pick and choose what works for you. Mesos doesn't provide any of that, but it does provide those primitives, and it sits in the middle. And what's really powerful about this is you can run 3 or 4 different types of applications on top of Mesos on the same cluster without having to essentially segregate your clusters. So right now, for instance, people who are running Hadoop jobs will have a Yarn cluster, and then they'll have a separate web services or microservices cluster, which might be running some sort of container management system. That's inefficient because, as I mentioned, these things have different usage patterns. So Mesos is kind of a nice way to put everything on the same cluster and ensure they're all isolated from each other. So just to summarize what Mesos is, it's a top-level Apache project. So it started off at Twitter. I think around the same time, or maybe before it went to Twitter, it joined the Apache incubator and then migrated to a top-level project. It has a significant number of committers. The majority of them are at Twitter and at Mesosphere, and then we have several outside contributors from Red Hat and other companies. So the way to think of it, I think it's sort of hard to define, but sort of one-line summary of Mesos is that it's a cluster resource negotiator. So it basically brokers resources between the worker nodes and the applications. Mesos scales. It scales really well, and this is not something that's happened overnight. It's taken 4 years of testing at Twitter to basically scale to this size. So I think the largest reported Mesos cluster was 15,000 nodes, and so it works, and that's just a single Mesos cluster. Most people will run a couple of clusters, but you get the idea. It works really, really well. And like I said, we like to think of it as this SDK for distributed apps, and that's actually something we're working a lot on at Mesosphere, is to make it really easy for people to build applications on top of Mesos. So these are some of the companies that are using Mesos in production. Twitter, I mentioned, is our biggest use case. Airbnb also runs all of their data infrastructure on Mesos. eBay does some really interesting things. If you're interested in continuous integration, they have a really interesting use case. If you look up, they have a blog post which talks about how they use Mesos to spin up a Jenkins instance for each developer. And this is really interesting because they essentially give each developer their own testing environment on the fly. And we really like that use case because it's very particular, but it's actually very useful. One more endorsement really is that a few months ago now, Siri, or the Apple team at Siri team at Apple, announced that Siri is powered by Mesos, and this is something we're really excited about because we've known they've been working with Mesos for a long time, but they obviously thought it's worthwhile sharing with the world that they run, I think it was in the order of tens of thousands of nodes running Siri run on Mesos, and they found out of all their options that Mesos was the most scalable and the most robust, which I think is a great endorsement. So I mentioned Marathon repeatedly, and you'll probably wonder what that is. The best way to describe it is as a self-hosted platform as a service. So Marathon, as I mentioned, is a framework on top of Mesos. Marathon has its own concept of applications, and there are a couple of other concepts related to applications, but the most fundamental concept here are applications. And these are things like services running in your data center. So this is our internal Marathon instance, which we use for dog fooding. And you can see we have a number of tasks running. We have a CPU wasted task, which thankfully is suspended. We have Kronos, which is another Mesos framework. And a few other sort of, like we have our wiki, for instance, hosted on here. This was just us testing it, HDFS, a few other tasks. And this is really cool. So it has this really nice user interface. We can kind of go in, see what tasks are running, see if they're healthy at a glance, and so on. And as we'll show you later, it has a really nice REST API too, and we now have our sort of command line tools for this. So it's very easy to manage applications running here. So this is one of our test tasks, and essentially this is showing a few hundred tasks running. So I think it's 10 in this case. We use this to basically scale test Mesos. And it provides this really easy interface to see where your application is running, what host or pod, when it started. If this had health checks defined, you'd see a little green traffic light or not next to each task. But this is really useful. And so this is how Mesos and Marathon work together. And this is sort of a general model for all frameworks, but I thought it'd be useful to, and schedulers, but I thought it'd be useful to explain how Marathon works, 'cause we'll be using that for the tutorial later. So in this example, we basically have an application in the white box, which a user has specified. So in this case, it's a very simple application. We pass in a URI. The URI is the artifact to unpack. And what Mesos does is it fetches that URI when the task starts and extracts it, and then we'll run the command, in this case, start. We also specify the resources we want to give this application, so how many CPUs, how much memory, how many instances we want to run, and we post it to Marathon using the REST API. Mesos will be offering Marathon resources periodically. That interval is configurable, but I think it's usually about 30 seconds. And you can make it go faster if you want things to launch quicker. The scheduler, in this case Marathon, will basically take one of these offers that says, okay, I have an application I want to run now, and then it accepts the resource offer by sending a launch task message. Along with the launch task message, it sends a task info, which basically describes the application it wants to run. So this is, like how many resources it wants, or how many instances it wants to launch, the URI, that sort of thing. Mesos takes that task info and figures out which worker node to send it to, and sends a launch task message to that node. The launch task message then sets up an executor. An executor is more of a complex topic, but it allows you to have some efficiency. So you could have an executor running perpetually on a node, and then it only fires up when you have a task or some work to do. This is useful for things like Spark, where you want to have your cluster running all the time, and you only want tasks to start when you have work to do. But in this case, I wouldn't worry about it too much. We launch our task, and then once the task has been launched, it sends status messages back, and Marathon basically keeps it. Mesos posts it to Marathon, and Marathon keeps track of the state of the task. So it's quite exciting. So you can see that, as I mentioned, you can start, stop, scale, and update apps. Scaling is a really fun feature because you can just type in a number, hit go, and Marathon goes and does its work. It has a nice web interface. It has an even nicer API. And we're working on bringing the interface up to the API, but they're almost feature complete, or feature parity. A Marathon by design is highly available. There's no single point of failure. So you can run 3 marathons, and they're all backed by Zookeeper. So Zookeeper figures out which one is in charge or which one is leading, and that works really well for most people. Marathon and Mesos actually have native Docker support. So using the API, you can specify a Docker container. This can be a public registry or a private registry. Marathon will go run it via Mesos, and Mesos knows how to pull these things from Docker. We've actually had Docker support for 9 months now, I think. Official native Docker support. We've had Docker support in one version or another for, I think, almost 2 years now. So it's definitely a very integral part of Mesos. We're also working on, I think it's called Rocket. I'm not sure if it still is. We're working on other container integrations too. We also have a pluggable event bus, which I think is interesting. So if you have monitoring systems you want to hook up to Marathon, so one of the interesting things people do, for instance, is hook up their chat channel to Marathon. So you get a message every time someone deploys a new version of an application. That sort of thing is very easy to do with Marathon. This is my favorite set of features, really, because I think we termed it deploy like Facebook, because you can imagine for an application like Facebook.com, you have, and they're very public about this, they have some really cool blog posts about how it's very difficult to update an application on a cluster the size of theirs without bringing down single nodes or taking the service down. So we have this set of features which is basically there to help people deploy applications at scale. And so rolling deploy is a really interesting one because you don't want to deploy a new version of your application until you're convinced it works. So this, in combination with health checks, works in a way that you basically configure a health check, update your application. Marathon will not kill off your old application until a new instance has come up and is happy and works. And you can specify the ratio at which it does this. So it will launch as many new tasks as it can. If it's set to the most aggressive setting, once all of those are launched, it will then kill off the old tasks, and your website is still up, your users are happy, your DevOps person is happy. Artifact staging is another interesting one. So this is the Facebook style deploy. If you have a few thousand nodes in your Mesos cluster and you want to deploy this application to all of them, how do you send that artifact to 1,000 nodes without bringing down one file server? In our case, we use HDFS, so you can stage your artifact on HDFS, and then Mesos will go and fetch it from HDFS. Okay, so now I'm going to try and go through a more case-by-case example of how an application launches on Mesos Marathon, just because there's a lot of moving pieces and it can be quite confusing. And in doing so, we'll show how Mesos basically handles all the different failure cases. Like I say, Mesos handles tens of thousands of nodes, and it wouldn't be able to do this if it didn't handle failure in an intelligent way. Twitter has a handful of SREs which run their cluster, and typically at other companies we've seen who have that many nodes, they have an entire army of ops people to run their clusters. And part of that is because Mesos handles these things fairly well. Okay, so this is day 0. We're at the beginning. We have a Zookeeper cluster, and we have a Mesos master. And we turn the Mesos master on, and it goes to Zookeeper, and it registers. Then we switch on a number of worker nodes, and the worker nodes all register with Mesos. First, they actually go to Zookeeper. Zookeeper tells them, okay, this Mesos master is in charge, and then they go and register with that master. The master then confirms that they've been registered. And then we switch on our framework, or our scheduler, in this case, Marathon. And Marathon will go to Zookeeper again. It will look up the IP address of the leading master, and then it will send a registration message to the master. And again, it's registered, and once Marathon is registered, it takes the framework ID that it's been given from the Mesos master and puts it in Zookeeper. And then the usual offer cycle happens. So Mesos will start offering Marathon resources. Marathon will decline the offers if it has no application to launch. And then our client comes along, and he's using the REST API, and he has an application definition, which is in JSON. Something like this. So this is similar to the example we saw earlier. It's an arbitrary table. We have a command, some parameters, a number of CPUs, amount of memory. Marathon now has work to do, so it sends a launch task message to Mesos. And Mesos says, okay, I know where I can run this, and sends a launch task message to one of the worker nodes. The worker node then spins up, so the dotted line here represents a sandbox. So this is a container of sorts that's using C groups. And so we have this sandbox area in which we can spin up this executor. And that launch task message then is fed to the executor, which then launches a task and sends a status update back to the Mesos slave, and then that sends a status update back to the Mesos master. The master then sends the status update to Marathon, and it communicates this back to the client. Your application is up and it's healthy. And we're in a nice, happy state of being. So let's deal with, let's look at task failure first. So let's say someone writes a bad application, and we get a seg fault, and the application goes away. The Mesos slave is monitoring the running tasks and executors on that machine. It sends a status update to the Mesos master. The Mesos master then communicates this to Marathon. Note that Mesos itself doesn't handle launching new tasks. It delegates that responsibility to the framework and the scheduler. Marathon's like, oh no, I need that task running. So it then sends another launch task message to Mesos. Mesos then launches another task, and we're back again. Status update goes back to Marathon, and again, we're happy. Note that if your task is always going to fail, then this is obviously bad because it continually fails. And Marathon has some logic built in to basically do exponential backoff. So for instance, if your application continues to fail, it will try and launch it at fewer and or longer and longer intervals between each launch because it doesn't want to overwhelm your cluster with these tasks that will never run. This is also part of the health check configuration, I think, so that you can only tell, you can wait for a number of successive health checks before an application is considered unhealthy, health checks to fail. Okay, so this is a really interesting feature of Mesos, which is the local agent on the node fails. So on our node, we have this Mesos slave process and it fails. And why might this happen? You'd hope that the Mesos slave process wouldn't fail by itself, right? Because it's meant to be a production tested distributed system. This is kind of intentional actually, because if you want to try and upgrade a cluster of 10,000 machines, which is running in production, you have to allow for tasks to continue running while the cluster management software is upgraded, killed, and restarted. And so that's what happens in this case. We kill the Mesos slave process because someone wants to update it. The new one comes back, and what it does is it just reattaches itself to the running tasks. So it has a local store of what's running on that machine. It reattaches itself. It re-registers with the Mesos master. And again, we're happy. There will usually be some reconciliation involved too, if it's been a significant amount of time. And Mesos has robust primitives to allow for reconciliation of tasks. In this case, it wasn't necessary to do anything. Okay, so what happens if the node itself goes away? Let's say the network switch where that node is gets unplugged, or the hardware dies, the machine goes down. Mesos keeps track of this stuff, so if it hasn't heard from the worker node in a certain amount of time, it basically sends a status update to our scheduler, Marathon, saying, oh no, your task has gone away. Marathon then says, okay, that's not good. I want that task to be running, and then with the next resource offer, sends a launch task message to Mesos. Mesos takes that launch task message, finds another node for that task to run on, and the same business happens again, just on a different node. Status updates go back, and again, Marathon is happy. So this is one of the most terrifying failure cases, which is the master node goes down. No good. So in this case, another master node comes up and is elected leader. So leader election is a well-defined process supported by Zookeeper, where it essentially, given a set of nodes, works out which one should be in charge. So in this case, let's say the original master node has failed for whatever reason, hardware failure perhaps. Another node comes online. It is elected leading master by Zookeeper, and then Zookeeper communicates that information to all the nodes running in your cluster. Note that your tasks just keep running. There's no reason they should exit. The Mesos workers are happy as far as they know. The tasks keep running until they receive a stop task message, or I think it's kill task, or something like that. Everything just keeps running. So the slave nodes then re-register with the new master. The scheduler re-registers with the new master, and it confirms their registration, and it reconciles the list of tasks with all the running frameworks, just to make sure that its view of the world is the most current. And again, we're happy. Okay, so let's talk about framework failure. I realize I've been conflating framework and scheduler. Framework is a collective term we use for the scheduler plus the software it runs on the tasks, which is not the cleanest name, and it's slightly overloaded, but essentially a framework you can think of as a Mesos native application. It's a set of executables that run on Mesos. One of those executables is the scheduler. So in this case, the scheduler component of Marathon goes down. The tasks keep running because Marathon hasn't communicated anything else to them. Marathon comes back up, and it sends its framework ID to Zookeeper, because the framework ID is usually persisted and shared between the running Marathons. And then Zookeeper tells it, okay, this is the leading master. It re-registers. And then again, we do the reconciliation process, and we get the latest view of the world. And everything is happy. Okay, cool. So Jose is going to demonstrate the DCOS.
So for this part of the session, we'll try to do a live demo of DCOS. And DCOS is many components, but some of the components that what you saw there in terms of Mesos and Marathon. Marathon being our init system we're in charge of. You can sign up for Mesosphere DCOS by following this link. There you'll be able to get access to the public beta to download DCOS. I already have a DCOS running, which is here. I think it has a couple of nodes, nothing running really. And then we'll look at how we can use the CLI to manage our DCOS data center. This is how you install the CLI. We'll do that. We'll do another session where we actually get to play around with the CLI. I already have the CLI installed. Yeah. How's that? So for example, we have a command called Marathon for managing Marathon. So one of the main features that DCOS provides is the ability to install frameworks like Cassandra, like you can install your own Marathon too, or Chronos and things like that. And the main command to do that is package install, and we'll install Cassandra. And that goes ahead and install Cassandra, and I can see, for example, what's been installed. And I'll do some pipe magic here you can ignore, but basically I have Spark and Cassandra running. And if I do a DCOS task, which basically lists, as you saw in the previous diagrams, all my running tasks, I can see, this may take a little bit, all my running.
Can we see what it looks like in the UI?
Yeah, we'll skip to the UI. So these are all my running tasks. And basically at a high level, how Cassandra, the framework works is that you have a scheduler responsible for executing actual Cassandra nodes that are giving you the Cassandra cluster in database implementation. And in terms of the UI, we can see that we have this utilization, then we can look at, I think if I have this many tasks running, this much CPU usage and things like that. What else? We can install Spark. In this case, I'm going to tell it to only install so usually an application has two components. One is what runs in your data center, and another component is what runs on your the CLI. And in this case, I'm telling it to only run the app that runs in your data center. And then we can go back to services, and you should see Spark running. And then the cool thing, which I did it before, is I installed the Spark CLI before running this command, is we can do something like DCOS help, and we see Spark there as an extension point. I can say DCOS Spark help, and that would show what kind of things I can do with the Spark CLI, like run jobs and whatnot. And then I think we ran this command already, but I can do package list install and list the names, and I get all the names of the packages, and then just I can run the task. The next command that I want to show is we have like a simple hello world application that installs both a CLI and a DCOS application. And I'll just show that. So I can do DCOS package install hello world. And that goes ahead and installs the application on the data center and also installs the CLI part of it. And when I do DCOS help, I see that I now have a hello world subcommand. I can do hello world. This is not a very interesting command, but I have a hello world command. One thing that I want to show, and then if I do DCOS task, again, where's the UI? If we go to the dashboard, we should see more tasks, 6 tasks total right now. Higher CPU utilization, higher memory utilization. So we should see the hello world task running now, the Spark, the Cassandra actual nodes, the Cassandra scheduler. Then I can use Marathon to, for example, let's imagine this hello world is an HTTP server that's rendering your app. I can say Marathon update hello world and increase the number of instances to 5. And I can go here, I see 9 total tasks, 10, obviously my CPU allocation went up. And if I look at my nodes, I can see what is running in each individual nodes. And I can see memory usage.
You got the Marathon UI around?
We can try. And this is the result of task. I see now I have 5 hello worlds. And this is the Marathon UI that you may be familiar with. And
so
yep.
This is the start of the next section. Okay, guys, just that's the end of us talking at you, and now this is where you try and run the stuff that we tell you to, and it fails. But there's a presentation link again. So if you haven't got it open, this is probably a good time to open it. So how many of you managed to get the USB stick working on your machines? There's a handful. Okay. You guys are in charge of your rows. For the rest of you, we'll talk through a sort of hands-on with Mesos and Marathon. So let's get you set up first. So I'm actually, let's see, what's the best way to do this? we're going to show you how this works on my laptop. So you have 5 seconds more of looking at this URL while we plug in the laptop. Okay, now we're back. All right, welcome to my laptop. So I've already set up this. Okay, so I've gone to my memory stick, which is not working right now, but if I plug it back in, hopefully my Mac will recognize it. Okay, so I have my Mesosphere memory stick. What I've done is copy the Mesos USB folder over to my home directory, which is here. So I have this Mesos USB folder. I'm hoping you guys have got it this far at least. Then what I do is, let's make this bigger. So I'm in my Mesos USB folder, and I have this Mesos.box. So this next step you probably won't have to do if you haven't added this box already, but I'm going to go ahead and re-add it. Okay, so what this is doing is adding the local Mesos box, which is essentially a VirtualBox image, to my local Vagrant setup under the name Mesos. So this should be reasonably quick once you get it off the memory stick. Okay, so we now have added a box locally, and so we have this Vagrant file here, and the Vagrant file basically specifies that we should use this box and what IP address to bind to, and so on. So by typing Vagrant up, it opens the box. So it's running already. So I should point out that this box that this box that you have on the memory sticks is actually the open source version of all the stuff that composes the DCOS. So in particular, you won't have that fancy user interface. You will have, however, the open source Mesos UI and the open source Marathon UI, which should be sufficient to show you most of the cool things that Mesos does. Okay, so here we go. This is my local Mesos cluster. This box is already running. You can see that we've been trying to get our demo working with all these completed tasks. This is what the Mesos UI looks like. It shows you the tasks. You can see what frameworks are registered. In this case, we just have one. We have our Marathon, which is running on the same VM. We also have slave nodes, offers. This UI isn't the most it's an open source UI, so it's not the prettiest, but it is very useful. We have Marathon 2 running on the same node, and there's nothing running at the moment, but this is what Jose showed you just earlier, and this is what we spoke about earlier. It has this nice user interface, so I can go and create a new application very easily from here. We're actually going to show you how to use the CLI to do this. This will show you when you upgrade applications, the status of those deployments. But again, if you have a memory stick, you can play with this stuff at home. It makes good dinner table conversation too. So, right. So we've done that. What we're going to do now is collectively we're going to install the CLI. So memorize this URL, or hopefully if you brought up that presentation, you'll have this locally. What we're going to do is pull down the install script for the CLI. So it's downloads.mesosphere.io/DCOS-CLI/install.sh. So I've done this already, so I'm going to remove it. I'm also going to remove my local config. We start from scratch. and hope that the conference Wi-Fi works. All right. Here we go. Cool. So we have our install script. Again, this is not publicly available yet. It will be soon. But if you feel like playing around with the CLI before public release, this is a URL to pass on to your friends and post on WikiLeaks. Okay, so now we'll make an empty directory. And then we're going to run our install script. So we're basically telling the install script to install into this empty directory. And we're passing in a URL here. This URL technically represents your DCOS master node. Since we're not running DCOS, we're just putting in a value here, but it won't mean anything. And because of that, some of the functions of the CLI may not work as expected, but we'll work around that. So we hit install. And the CLI is available in PyPy too. If you feel like some fun, you can install it straight from PyPy, but I recommend using the install script just to make your life easier. Okay, so I'll ask you to authenticate with Mesosphere. This is some analytics stuff we use, but eventually we'll have a sort of, I guess, logged in experience. So we'll have access control and other things, which will all be tightly integrated with Amazon and Google. Cool, so we now have CLI installed. This line is important because it makes it possible to use the CLI. So if we copy that, what we're doing is sourcing a bunch of environment variables and adding the executable to our path. This is installed in a virtual env, so if you know Python, you know that's useful because it hasn't destroyed your local Python environment. Okay, so now this is fun because we have a CLI and we can go DCOS help, and what Jose showed you just now, you should now have running on your machine. The next important step is to set these values. So this is how we support the open source versions of the products, because within DCOS itself, we have, if you're using the sort of proprietary version of DCOS, we have some special networking set up. By setting these two parameters, these two config values, we're basically telling it to connect directly to Mesos and connect directly to Marathon instead of using our fancy networking setup. Cool. So now if we do DCOS tasks, we don't get an error message, which is good, which we would have got otherwise. Or if we do DCOS Marathon app list, again, we see an empty list, but no error message. Okay, so Jose is going to take over now and show you how to use some of the examples in the Mesos USB folder.
Okay. Let's see. So in that USB folder, we have this Mesosphere folder, and I believe here we have a Marathon example where we have, sorry?
Oh yeah, hit click. Yeah, awesome. Cool.
Okay. So we have the following, files. And they're basically app definitions for Marathon in JSON format. So for example, we can look at the first one. And the first one is saying, I have an application with this ID. I would like this many CPU shares, 0.1 CPU shares. I would like that much memory in megabytes, 32 megabytes. The port is saying, dynamically give me a port. The command line says run this command, and there's a magical environment variable there called port 0, and that will be populated with whatever the dynamic port allocation was, and then we're saying run 2 instances of that. So we can say DCOS Marathon app add that, and we should be able to put, let's see, if we ask Marathon to we're asking Marathon to list all the tasks running for that application. And we see that is running on the same host, because we only have one slave, I believe, on that, one node on that Vagrant machine, and is running in 2 different ports, and those 2 ports were dynamically allocated by Mesos. Let's see. We have an Nginx example. This one is using Docker to run Nginx. Similar is asking for that much CPU share, 64 megabytes, 2 instances. What else is there? Saying run the following container, which is of type Docker. It specified the image. You can find that on Docker Hub. The networking mode, which is bridge, and similar port mapping information. And we can use the CLI again. And we can list, the ID of this one is Nginx, so I can say Nginx, and then I can see my 2 applications running. Now for the next example is we want to run MySQL, also a Docker image. It specifies an environment variable, which is your MySQL root password, some constraints. This is saying that if I run multiple instances, it's not a good example in a particular environment because we only have one Mesos node, worker node. But this is saying if you have multiple worker nodes and you specify instance greater than 1, you do not want the task to run in the same host name, in the same host. Same thing, we specify your CPU shares and your memory. We can use Marathon. This was 2. We can see we have one MySQL Docker running with the following ports. And again, if we ask for all the running tasks, we see our HTTP server, our Nginx server, and our MySQL server. Okay. What else? We have toggle. So for this application, we are going to run it's a little different. Before we showed a command that already existed in the worker node, and then they also showed a Docker image or container being downloaded. In this example, we're actually downloading a tar that contains the executable above, which is the toggle.py. So what Mess is going to do is going to download that file, whatever it is. It knows to do certain things with certain file types. In this specific case, it knows to untar to unpackage that file, and then it will execute the command above. Is using a static port allocation, or actually that's a service port, and it's binding it to the port 0 variable. So in this case, I can do DCOS Marathon app add 3. Now is probably a good time to show you in the UI how this looks. So in the UI, we have those 4 applications that we deployed, and their instance running, the memory usage, CPU usage, and their health. If we go to Mesos, we can see similar view that we saw from the command line, which is these are all our active tasks for all the different applications that we executed. And for frameworks, I believe we only have one framework, which is the Mesos framework, which is this one here. Oh, the Marathon framework. Marathon also supports groups. which is a collection of applications that get deployed together. It could be scaled together. In this example, we have two group with two applications. One is service A, one is service B, and then an application called service common. And we can also use the CLI to do this. And the command is DCOS marathon group add. Sorry, what was this file? Group. Saying that there's an application that already exists. Let's see. Department A. Well, for some reason, it doesn't want to deploy. This group. Saying it already exists. Let's try removing it. Okay. So now we have a group running, which had three basically applications, and with a different number of tasks. And the same thing before, we can say, show the running task. Okay. Then we're going to show constraints. With the one we saw before, we had a constraint that said the hosts have unique. It has to be unique. This is another form of constraints. So this DCOS marathon add. Oh, so I have that application already running. So the easiest way to remove it is and then we see this app getting removed, and we should see it come back when the add happens. Or it's launching 16 instances, and that might take some time. Okay, the last command is this other one, which is a Docker container. It sets a bunch of environment variables. It has your CPU shares at 0.5, memory usage at 1 gigabyte, bridge mode for the networking, and some port mapping information. Oh. In this particular case, the CLI is complaining because it doesn't like the ID. It says the ID does not match a certain regular expression. I suspect it's the forward slashes. So it's probably a bug in the CLI. So we can manually do this. Or we can, yeah, that's probably easier. Let's try that. And we have Docker running. And again, we can see it from here. And that's it, I think.
Thanks, guys. We'll take any questions now.
Yep.
Hey, you mentioned there were two components to a Marathon app. What do I need to do to prepare my app to run on Marathon?
I think I might have said there's two components to DCOS service, which one is the framework that runs on your on the data center, and that's usually executed through Marathon. And another one is a CLI component that you can use to manage that service.
The CLI is optional, basically.
Yeah, there's, I don't know if we have an example, but there is, if you're using Marathon, I'll put one of them. There is a property here called user, and there you can specify the user that methods are supposed to use when running it on that particular worker node. It has to already exist. You can obviously run obviously run commands as root to create those users using methods, but yeah, you have to make sure that your environment is set up correctly. Yep.
Just a quick update for the documents. If people are getting virtualized on Python, they're trying to run the installer, you have to put the installer virtualized.
Right.
Because it's not in the maker class, so the directional code actually works.
Okay. Sorry about that.
So we can use the DCOS command line to add frameworks, and I thought you could also use it as Marathon. Presumably that's scheduling out that response currently. So what's the actual scheduling running at?
So we have a root Marathon. So we use Marathon to run other frameworks. So we think of it kind of like a meta framework, because Marathon can run anything that is an executable. And so it's nice running other frameworks in Marathon, because Marathon has these nice features to restart things if they fail. So one of the things we didn't show is you can do DCOS package install Marathon. So you can install Marathon on Marathon, which means that you could give every developer their own instance of Marathon if you wanted.
So it assumes a running Marathon. And if you run Marathon again, it's scheduled.
Yeah.
You can think of the Marathon as, you know, that systemd or that upstart that is the first program that is able to run other programs. But yeah.
Right, over to the right there. I think it's just you, yeah. Mm-hmm. Yeah, so the way persistent volumes, I think they work hand in hand with another feature, which is dynamic reservations. And so the idea of persistent volumes is that your framework, which requires persistent resources, can pin itself to a node. And so it's still up to your framework to figure out how many nodes it needs to run and how to replicate things amongst itself. It just means that if your framework goes down and comes back, or if that node goes down and comes back, that framework is able to reattach itself to those persistent resources on that node. So the failure state is left up to the framework, but Mesos will make sure when it's implemented that the framework gets back to its data, basically. Yeah, what other
Show
constraints are there?
The help probably. So the best, oh, not that. If we go to docs, all this stuff is documented. This, you can get it from your own, Marathon has a link to our hosted documentation, or you can follow this link, or you can find this link through the Marathon project. But here we specify all the constraints. There's host name, there's attributes, because a Mesos slave can have, or a Mesos worker, when you start it, you can specify attributes as that worker has, and those get propagated or they offer back to the scheduler, and you can use those for constraints. You can create an attribute. I'm not sure if I follow your question, but you can have the worker be set up with any kind of attribute. For example, let's say that you have hypothetically a set of nodes that have GPUs on them. You can, when you start the worker, you can say those nodes have the following attributes, and you can use those attributes in your scheduling algorithm. Yeah.
Over here.
So you asked the question, verification doing the
Oh, so there should be a URL that is printed out. If you paste that into your browser, yeah, cool. Yes. Okay, so the question was about disk type. So if Mesos can detect what kind of disk and characteristics of the disk running on the node. That's at the moment up to the user, so you would have to add an attribute, similar to the GPU example he mentioned, but feasibly that could be something that gets implemented.
The other thing is that when you started the application, you mentioned about memory CPUs. So is the scheduler, let's say my resource, my cluster is empty or not using any resources, can that job use more resources?
Then you gave it when you started it?
Yes, because the cluster is empty and not being used.
You're only allowed to use as many resources as you've been allocated. You're the running application, but you can always request more if they're available. Yeah.
But there is a feature being implemented now, which is dynamic reservations, where you can say, reserve this for a particular framework, and when that framework needs it, it will kick off tasks that are being eagerly scheduled. So you can say, let's say you have your HTTP server and you're running Hadoop jobs eagerly. If at one point that HTTP server needs that reservations, then it will kick off the Hadoop jobs, for example.
Yep.
In some of the early demos in the CLI, there was some like failure testing, benchmarking, stuff like that. Is that open source?
No, it's currently only for the. It's currently only in the very early version of the CLI. But if that looks like something our users want, we're happy to prioritize it. Just sign up to the beta and shout about it on the public channel, and we'll try and get one of our product managers to prioritize it. Yeah, at the back there. So there's a few different answers to this. So Mesos DNS does something clever with port stat. Do you know how Mesos DNS works with ports?
Yeah, it'll get it on the task.
But you can use Mesos DNS to go straight to an application without having to look up the port first. We also, ports are a very confusing concept in Marathon at the moment, which we're trying to improve. But there's this idea of a service port. And that's a well-defined port for the service that doesn't change. So you could say, I don't know, my API server runs on 8080. And then what people also do in conjunction with that is run HA proxy on each node, which remaps the service port to the port that it's actually running on. So your application that uses that API server would be configured to look for 8080, and then HA proxy would remap it to the actual port and redirect traffic. So there's a nice tutorial on the Marathon. I think it's on the Marathon. Yeah, here we go. Service discovery and load balancing. So there's a short tutorial here. There's a longer one on the Mesosphere website, which shows how HA proxy works with Marathon. Yeah. Anyone else?
As far as
your worker nodes go, how do you find, what are some ways that folks find good balance, ways to balance out the compute, memory, storage resources for clusters so you don't have run out of one thing first before you run out of something else? How people approach that?
That's a good question. I'm not entirely sure.
I'm not sure I follow your question. Sorry.
So how do people figure out which resource is being most disproportionately used?
Your cluster of physical nodes are in balance.
Right. Unfortunately, from a schedules point of view, you have a subset view of what the data center is, which is what the offers that Mesos gives you. I'm not sure if I can answer how Mesos, because it depends on your load. If your loads are memory heavy, then you are using more memory than CPU. I think I would say that as a manager of the data center, you want to make sure that you have loads that utilize all the resources that you have, or get the right nodes for the loads that you're trying to run.
Well, one of our biggest customers, the people who have ridiculous utilization at 90-something%, they use a custom monitoring process running on each node to basically keep track of the available resources, and that sends data to a central, I think it's Riemann server, which basically aggregates all of the resources and calculates the total utilization for the cluster. Again, we're hoping that with the DCOS and with the new tools we'll be releasing for the DCOS in the future, that will basically be a lot easier to manage as an operator, because we'll show you that data. But there's no canonical solution yet. Anyone else? Oh yeah, sorry. Yeah, that's a really good question, and we don't have a good answer for that. In that it almost has this very simple model of resources, where we don't consider the fact that resources can be very different, even if it reports the same number of CPUs. Yeah. Exactly. So that's the way people do it. So constraint attributes on nodes, and then constraints combined with those attributes are a way people basically classify their hardware. So the SSD example is a good one. At Twitter, I think they have nodes with SSDs which are tagged with the SSD tag as an attribute, and then okay.
Yes. Another thing to understand too is that those the CPU-S, they're not actually number of CPUs. They're CPU shares. So, for example, if you have one machine that has one CPU and it's let's say 4 gigahertz, and then you have another machine that has one CPU and it's 2 gigahertz, you can give it different shares when you start up your node. So then they're not necessarily the number of CPUs, but the shares that CPU or the share that node has available. So you can have different values depending on things like frequency or things like that.
Okay, cool. Okay, yeah, over here.
Do you have any recommendations or tools when you go for upscaling, managing the scale automatically?
For what? So we don't officially provide anything for auto scaling.
For auto scaling your task?
For your cluster.
Right. Yeah, we don't have a pre-packaged, easy-to-use solution, but there are plans to have a monitoring service that monitors your application. For example, you can monitor latencies and things like that, and that feeds back to Marathon. And you can have potentially, if your application is stateless, you can just say, hey, my latency has increased by this much, increase the number of instances by this much, and hopefully your latency will go down. Obviously, different applications will have different rules for those. Right.
That's what most people do, yeah. Cool.
The discussion is around availability, especially in response to the regional failures or the cluster. So is it possible to manage some clusters and stays in cluster in one region and some other clusters and stays in another region so that one cluster goes
So the question was about region awareness to some extent. I'm not sure. So our official answer is that Mesos doesn't work very well across data centers because there can often be networking issues. We're working around that actually, and one of the projects we're very excited to work on at the moment is, you may have seen this, actually, I don't know, was it demoed at the Microsoft conference?
Yeah.
Yeah, the cloud dial thing, where you can basically spill over from your local data center into the cloud. So part of that feature is being able to work across regions and data centers, but at the moment we don't have it will work, it just won't work very well. So you could feasibly do that. You could try it. You could run a master in each region and see how it works. You might find that you run into some bottlenecks very quickly. Yeah.
Do you manage your HDFS stuff in Mesos, or do you run that separately?
So most people currently run it separately, but we've got a beta framework out which actually runs HDFS on Mesos. Once the persistent primitives, the features to support persistent volumes go into Mesos, that framework will become a lot more robust because then you can get back to your data. At the moment, it's a little bit sketchy if you run HDFS on Mesos and a task fails because you won't be able to recover the data that easily.
When is the feature supposed to be?
The schedule for the next major release of Mesos. We just had a bug fix release go out last week, I think, or the week before. So I imagine probably within a couple of months. But I know that team is working really hard on getting the API locked down right now. So, yeah. Any other questions?
So if you install an app and you're running through a volume, you're storing data there, and that node is just goes down, crashes, how does that actually do failover? Do you have to just run up another thing from that app to bring the volume back? How does that volume recreate the data?
So the persistent stuff is not yet available. So right now what would happen is that data would get wiped. So most people, the way they do it at the moment, if they're running anything that has persistence, is they'll delegate to another storage system like HDFS. So a very typical pattern right now is to run an HDFS node on each machine and a Mesos node. And so you have your data sort of layer on the same set of machines as your services, and they can just write to it. No, it's actually primarily built for, well, it's not built explicitly with the goal of working across the data centers, but that's where we're going, yeah. Yeah, that's a good question. So the question was, how do you handle the time delay with Zookeeper trying to get consensus across data centers? And I think that's probably one of the main reasons it doesn't work very well right now. But I'm afraid I don't have a good answer for that at the moment. Okay. All right. Well, we're going to be here for a little while afterwards, so come and talk to us if you have any questions. But otherwise, thank you for attending and hope you manage to get your Mesos clusters up and running soon.